Okay, our next question here, number 15. What is the length of segment DE? Last sentence always first. DE, right here is what we care about. We'll fill in the rest of the information. BC is 5, and AD here is half the length of CD. Okay, so if I called CD, for instance, 2x, then I could call this x, right? AD is half as long as CD. It's worth avoiding fractions, perhaps, when you do this. All right, so what do we know? Okay, let me draw. Sometimes I think it's useful to draw the triangles when they're not overlapping. Here's the big triangle, B, C, A, and this is 3x, okay? So now the triangle, what we're asked about, this little guy, could be written as a triangle with side lengths. Here's A, and D, that side length from A to D is called X. We just labeled it that. The thing we care about, I'll put a little question mark there to emphasize that that's what I care about. And I'm asked to deal with these two triangles, and there's got to be something about these triangles that are the same, right? One of the things that's the same is that we have angle A, and we have a right triangle in both cases. Okay, whatever angle A is, it might be helpful to call it something like, I don't know, 20 degrees. We don't know that it's 20, but we also don't know, it could be anything. And for our purposes, this will do just fine. 20 and 20 would imply that this is 70 and this is 70. Now, if we have angles that are all the same, then we have similar triangles. And this could be done without using real values too. You could just say, call this angle A, call this angle A, and you could do a little algebra to prove it. So if you feel strangely about my use of throwing a random value in it, we know that we have 180 degrees in a triangle. Let's subtract the 90-degree angle from here and here. That means what we have left is 90 degrees. 90 degrees, that 90 degrees is what you call this angle B if you want. Well, 90 degrees has to be A plus B, and B could be written by moving A over, subtracting A as 90 minus A equals B. Okay, well look, down here, if this is A, and 90 minus A equals B, then this is B. Right? Because these two angles have to add up to 90 as well. I'll get rid of the algebra here and just go back to saying we have similar triangles. In fact, I won't. I'll just leave it right there so we can now work with that information. Okay, similar triangles means everything from the small triangle is in proportion to the larger triangle. X, 3 times bigger for 3x. Question mark, 3 times bigger is 5. So maybe the other way is a little bit easier. To get from 3x to x, we divide by 3. To get from 5 to our question mark, we divide by 3. So our question mark is 5 over 3. 5 divided by 3. And there's our answer, right? So similar triangles, once again, you'll see that stuff showing up everywhere on this test, all over the place. Let's continue here. Another circle question. And in the case of this circle question, what I'd like to do, just 1 second. Something I say to folks all the time on questions on the SAT math section and in the ACT is if you give me points and equations, I'm putting them together. Right? So we don't know what the radius is here yet. In order to actually use these points in a meaningful way, we'll have to use the radius. But one thing we do know is that these are endpoints of a diameter. So a rough sketch, 2, 4, and -2, -4 would get you here and here. And people think about distance formula as if it's something, more specialized than it is. Basically, distance formula says, figure out your horizontal distance. I'll use purple here. The distance from -2 to +2 horizontally, and that distance is just 4. And the distance formula says, figure out your vertical distance. And from -4 up to +4 is a distance of 8. Okay, so now I can just think in terms of Pythagorean theorem. 8 squared plus 4 squared equals the diameter squared. That's 64 plus 16 equals diameter squared, and that amounts to 80. Okay, so there's a shortcut here using the answers. Our equation is not diameter squared, it's radius squared. It may seem you may be expecting to see half of this value. Of course, we could take the square root of both sides. We could do some work. Basically, I know that the radius is not the diameter squared is not the radius squared. So these are wrong. If you're a little bit perplexed by that, you're not alone. Let's talk about why. If you wanted to solve for the diameter, you'd square root both sides. So you'd say the square root of 80 equals the diameter. And if you wanted to solve for the radius, you'd divide diameter by 2. And root 80 over 2 is not root 40. Root 80 over 2, for instance, can be written as, I'll go over here where I have some space, root 80 over 2. What does this equal? Well, root 80 could be written as 4 times 20 under a square root times 2. And then that is equal to the square root of 4, properties of square roots. You can, if you've got multiplication or division, you can split these up into separate roots. And root 4 over 2 is just 2 over 2 times root 20. So the radius is not root 40, it's root 20. And the radius squared is 20. But notice all of that work I just did in red, I should say not this work was useful, but all of this work to solve for radius was completely unnecessary. Because if I know the diameter squared is 80, I know the radius squared is 9. Okay? So that's sufficient to say, okay, these are the potential answers and these are out. And then all I have to do, as I mentioned, my figure, go back, kind of suggests that the center, if we have a diameter, then the center is probably halfway in between at 0, 0, which, this is suggesting the center is positive 2, -4. That doesn't make sense, so here's our answer. But remember, also, as soon as you've known the radius, you could just put the values in. So you could just say this set of values, 2, 4 or -2, 4, have to work in our equation. We've already crossed off C, we've already crossed off A, and this set of values, 2, 4, certainly works in this equation. That would be 2 squared plus 4 squared. In other words, 4 plus 16, and that does equal 20. Over here, if you put in those values, let's see what happens. 2 for x means 2 minus 2, or 0 squared, plus 4 for y plus 4 is 8 squared. And of course, that does not equal 20. That equals 64. Out of curiosity, I'm kind of wondering, certainly I know if 2 squared plus 4 squared does equal 20, it doesn't equal 80. But I wanted to look really quickly. Yeah, this one won't work either. I wanted to just check in on that because I was kind of thinking, I wonder, I said at the beginning we needed to know the radius. I guess the truth is we didn't need to know the radius. This value, this set of values, x and y, have to work in our equation. And in A, we'll get 64 equals 80, right? 0 plus 4 plus 4, 8 squared. So using the value here would not work, nor would it work here, nor would it work here. So once again, if you have values, and you have equations, bringing them together might be the most efficient way to solve. You wouldn't even have to know anything about circles in this case. Okay, so I hope that's helpful.